Okay, so moving on with Poissons ratio. So this is read as Poisson. I think it's in French. So Simeon Poisson is a French mathematician. So that's why it's not Poisson. So probably you can read this as Poisson for you to read it easily, or in an easy manner, or kana magdali kag basa, so pwede Poisson. But the correct pronunciation is Poisson. So in this topic, we'll be discussing the relationship between the strain behavior of both directions or both axes. So it may be on the X and Y simultaneously, and X, Y, and Z simultaneously. Okay, so so Poisson's ratio. So there are three types. So we have the uniaxial loading, or what we call as one-way loading, meaning only one axis has been applied with the load. We have biaxial loading, which is two axes has been applied with the load. It may be X, Y, or let's say X, Z axis, or Y, Z axis that has a load. Okay, so it's read here that the deformation of a member in the axial direction induces deformation in the transverse direction. So meaning if we are trying to um, say ko na. So if we're trying to, let's say, put a load here on the x-axis. So again, by basic definition of strain, we can expect some deformation or elongation with respect to the x-axis. So of course, if we try to imagine it in actual material, so if we probably stretch the x-axis, so the other transverse axis might as well um, shrink, di ba? Or let's say expand depending on the behavior of the load. So in case of this being tension, so we can say that there's a uh, probable shrinkage in the y-axis, di ba? So let's say this is the original material, kaning naka-hidden line. And then let's say this one is now the new um, member, the elongated version of the member, kaning taas. Oh, sorry. Okay, so notice that the x-axis has elongated, but the y-axis or its transverse axis, rather the opposite direction, or what we call as the perpendicular axis of x. So we can say that the y-axis has shrink, di ba? So marag mo na siya inyong tanawon. Okay, so Simeon Poisson showed that the ratio between these axes, the x and its transverse axis, is experiencing a proportional or somewhat directly proportional strain with respect to the stresses that it has experienced. So of course, these stresses are just within the proportional limit. So again, proportional limit, as what we have discussed last meeting, is just um, the stress and strain on that particular line, wherein even though that there's deformation happening, the material will still go back to its um, original shape or original position. So mahitabo na siya beyond the elastic limit where the deformation is permanent. Okay, so if you can see here in the formula, so we have, I think this one is new, small Greek letter nu, and this one is epsilon. Small case, right? I think it's small case also, epsilon. Okay, so the Poissons ratio is being defined as the negative change in, rather it could be negative or positive, but in our example it's negative. So that's why we have the negative sign here. So it's the negative. So again, since it's a ratio between the strain of the axis, the axis, so that's x and y axis. So first is we have to get the effect of the transverse axis, which is in the numerator here, found here. And then this one is the other axis, x-axis. Okay, so as you can see, the Poisson's ratio is being defined as the ratio between the transverse strain towards the axial strain, or where the load was applied with. So notice that the strain in the transverse axis is negative because, as what is shown above, since the axial axis is experiencing tension, so this one is elongation, diba? So notice that the denominator is positive. So again, since the y-axis is shrinking, so we expect contraction, diba? So again, if contraction, that would be negative strain. So that's why it's negative here. So nu is equal to negative epsilon sub y, or rather you can just read it as the description states para dili kayo maglibog. So Poisson's ratio is equal to the negative strain sub y divided by strain sub x. Ano lang siguro. So ato lang siyang i-sub-sub lang. Okay? So next is we try to isolate the strain on y so that we can know what its particular value is. So pretty simple. You just have to rearrange the equation by isolating epsilon sub y. And this will give us this equation. So epsilon sub y is equal to negative nu epsilon sub x. Okay. So take note that in our previous discussion, the stress is equal to the the modulus of elasticity. So and erase na naman. Na-erase po diya sa inyong kuan, sa inyong screen.
Yes, sir.
Noon tayo may laptop na ko eh. Wala po kay erase, na-erase siya kaya. So anyway, so going back, it's, so again, as what we call the modulus of elasticity is the ratio between the stress and the strain, di ba? So previous discussion. So I hope that you remember that one. So of course you can try to isolate the strain. So isolating strain by rearranging the formula is we have here stress all over the modulus of elasticity. So that's why we can plug this one inside the equation, whatever or whichever the axis you are referring to. So that's why, as you can see here, incorporating Hooke's law. So we have the term here, sigma sub x divided by the modulus of elasticity E. So again, it came from this particular parameter. And again, that is coming from Hooke's law, which is the the E is the ratio between the stress and the strain. So if you have here the final version of the formula, you have here epsilon sub y is equal to negative nu times sigma sub x all over E. So again, this is just pertaining to one direction. So you may also have other versions for this one. So for example, the y-axis is now loaded, and and then you tend to look for the deformation on x, diba? So meaning na starting with this one, so ma-reverse siya, diba? Because the loading is now present in the y-axis. So mitawa na if it's y-axis, so that's nu is equal to negative epsilon sub x all over epsilon sub y. Then you're going to have it as epsilon x equals negative nu epsilon y. So magbali-bali na siya, di ba? So think of it as a two-dimensional strain. So x and y strain or y or na siya, x or y strain. So probably there IZ, but that would be for multi-loading strain. Okay, so if you try to have the other formula, this would be this one. So also take note that the stress here can be replaced also or can be further refined into its basic concepts, which is force over area. So pwede pa dyan na siya ma-refine further, di ba? It will depend on the problem that you are facing with. So probably the problem will be asking for the force, or let's say we'll be asking for the area. So the formula may be further refined by replacing the sigma sub y with its further definition, which is force over area. And also for the strain, labi na katong elongation, di ba? So elongation is, I think the formula for that one is the strain is equal to the elongation or the deformation rather divided by the total length. It's the other definition of strain, di ba? So strain is the deformation all over the total length. So you can also do this one if the problem is asking for further refinement sa iyahang sa pag-asa details. So for example, what would be the total length if the strain is limited to this particular number? What would be the deformation if the length is only this tall, or is this or is this long, di ba? So it will depend on the situation that you will be having. Okay, so for a while, class. Okay, so to continue, is we now have the biaxial loading. So in biaxial loading, as you notice here in the screen, is that the material is now experiencing two types of load. So one is coming from the x-axis, the other one is coming from the y-axis. Okay, so of course so that's why it's called biaxial loading. If you try to imagine, so if you try to buy a clay man siguro, ano lang siguro clay, or let's say you're going to let's say kanang bread lang siguro para mas barato, di ba? Ang clay kay mahal-mahal man ang clay. So if you try to extend the bread in one axis and then also try to spread it in another axis, let's say the X and Y axis. So notice that the behavior of the material will have two different types of strain, diba? So of course, if you try to isolate first this particular P sub Y, and just imagine first the elongation of the X force. So if this one is elongated, so the other one will shrink, diba? And then, so kani siya, diba? Kani siya. Muna siya yung first behavior, diba? Okay. So much like the same, if you take it um, in isolation, let's say P sub X is a uniaxial load and then P sub Y is the uniaxial load. Then you try to combine both. So that is what is going to happen in your material, diba? So like there's a contraction and elongation in both axes. So x-axis will elongate, but probably it will contract back because of the axial loading in the y-axis also. So in the y-axis, even though that the x-axis is making it shrink, but mo elongate po siya, di ba? So mura siya kanang nag-push and pull sa iyahang strain in both axes due to its loading. So of course, we don't know yet the real um, deformation of the material because we need to quantify the loadings in your x and y axis nga kuan nga plane, di ba? So that's what we have to observe in this. Okay, so probably you'll get confused on why is it presented this way. So nu is equal rather epsilon sub nx equals agoy na yung nag-sign out. Okay, so epsilon sub nx is equal to epsilon sub double x. So if you're going to look for the different terms in the figure, so epsilon sub double x would be this one. So it's just ikuha lang siya sa iyang deflection, represented as the deflection. Okay, so notice that the n sub x is lesser than the deformation sub double x, because again it will be taken away with the deformation that will happen or the strain that will happen in the y direction, which is the contraction part of the material, right? So even though that it has expanded in this particular manner due to the uniaxial loading by the x-axis, so the net strain that the x-axis will obtain will be this one because it will contract due to the uniaxial load that is happening in the y-axis. So muna siya lisod siya i-imagine, but if you try again to some have, let's say, clay or kanang bread na inyong mas stress sa inyong balay. So pili na siya, let's say, or pili siya siguro sponge, di ba? If you have the sponge for your dishwashing, so pili sa ninyo na buhaton, mag-stretch mo na siya para inyong ma-imagine ang inyong strain. Okay, so same goes for the y-axis, is that again, this would be our net force. This would be the net deformation. So even though that it has expanded at this very large portion, but again, there will still be a contraction due to the x-axis, di ba? Push and pull man sila kay dungan man sila, it's biaxial loading. So I hope that you can imagine what I'm trying to say, di ba? So x-axis, if you try to stretch the x-axis, so the y-axis will shrink, di ba? So may one great example na, let's say you are trying to eat candy kanang murag kuan. I think it's tawag na mga kanang siguro sour tape, di ba? Or let's say kanang murag circle. I don't know really the exact term for that one, but kanang murag circle na candy. I think it's licorice mas na siya. And I'm not really sure for the exact term. So if you try to expand that one, di ba? So mura siya mo nipis og maayo, di ba? Or let's say you're going to try to imagine some noodle, di ba? Kanang one noodle nga thread. So if you try to extend that one, so even though nga mo break siya, so mura siya manipis og maayo, di ba? Before it will break. So yan na siya pag-imagine. Or let's say a dough ana, di ba? Kana sa pizza or sa bread before siya maluto. So it's super malleable material, di ba? So if you try to extend it in one axis, so mo siya manipis ug maayo, di ba? In the y-axis, so the x-axis will also shrink. So maginana siya pag-imagine. Okay, so the net. So let's go back to the discussion. So this is the net strain along A, rather along X. So the net stress, so again, this is the net stress. So probably in most books, you'll be just encountering this term here. Ana siya dito, muna siya unified na version na dito for biaxial loading. So wala siya nag-n sub x. Will be the strain, the total strain experienced by the x-axis minus the strain in the x and y axis. So again, this strain is caused by the axial load, axial by y-axis. So that's why it's negative, diba? Because it's contraction. Okay. So of course, this one is elongation. Okay, so again, by formula of the strain, so you can have this one as this type. That would be the sigma sub x divided by the modulus of elasticity. Okay, so again, this formula is coming from Poissons ratio, as previously discussed, this one. So this one is Poissons ratio. Okay, so that's why you have two different terms. So of course, again, as what I have discussed previously, this one can also be further refined. Excuse. So again, I think this is Hooke's law. Hooke's law, and then this one is another Hooke's law. Okay. So the final format for this one is this. So epsilon, the net strain in the x direction, is equal to 1 over the modulus of elasticity E multiplied by the difference of the stress x minus nu stress y. So in other books, probably you can see another version of this one. I think this is sigma sub x is equal to, let me try to remember. Basta na siya 1 minus v squared na. Okay, nawala akong papel, nilupad akong papel. So Mariana siya. So if you try to rearrange the formula and you're looking for the stress part of the problem, so there's a manipulation of this one. So na siya manipulation method diri sa inyong problem. And then what will happen is the sigma sub x will become isolated, and then there's a new format for the equation. So I think it's this one man siguro. Epsilon sub x minus nu epsilon sub y, then multiplied by e. So I think that's the other version of this formula. So just try to look for your reference. So nana siya sa libro. So probably I already gave you the link where you can download the book, especially other books. So hopefully that you can read those materials. So nasa dito sa formula. Ano siya? So also for the y aspect. So probably you'll be asking why it's combined. So there's what we call a method of superposition, wherein you take items individually and then combine them later. That's what we call a superposition. Imong ipatong-patong din afterwards ba? Or combine afterwards. So that's the superposition method. So probably in the later topics, there's a topic for superposition wherein you'll be dealing with a lot of formulas. So for now, let's just deal with strain. Okay, so let's try to get now the net strain along the y-axis. So this is the y-axis. So bali na sa, di ba? So the net in the y-axis is the difference between the total strain in y minus the strain in the the y and x axis. So again, total strain in y, so meaning this one is caused by the axial loading itself, axial loading of y. This one is caused by the axial loading of x. That's why it's sub epsilon sub yx, meaning the strain is happening because of the load in the x-axis. So same goes for the previous slide. So ano siya, ang first term is referring to the strain caused by the y load alone. The next term is the strain caused by the load on the other axis. So na siguro siya pag understand. So again, with the process of refinement, so you can further refine the equation by having this one as sigma sub y divided by e. So again, this one is you'll be using the Hooke's law, which is epsilon equals sigma all over the modulus of elasticity. And then this one is used using Poissons ratio. So if you try to imagine the biaxial loading, so if you notice that if we are not looking for the net strain, so murag might if ato siyang side by side, so the y aspect would just be in this manner, di ba? Epsilon sub y is equal to negative epsilon sub x, di ba? Nu. So notice if you compare it in this term here, so murag ang wala ani is kanira, di ba? So I think murag-mura na siya mapuno sa inyong biaxial loading. This particular term here, which is the total the axial load caused by the y load. So meaning ana murag di ka mo take into account the effect of the other axis. So muna siya. Okay? So again, try to derive the formula as much as possible for you to be able to understand kung saan niya pag break down ang iyahang details going towards the equation. So, amo na siya inyong dapat buhaton. So, again, this one is still Poissons ratio with respect to x-axis. And again, I think the other term for this one is, so the same as the other one, is still this epsilon sub x y dy minus epsilon nu is nu epsilon x times e all over 1 minus v squared. So mark mo na siya ang other version of this one. So just try to look for this one in the PDF file. So that's the other version of this one. Okay, so by axial loading, medyo labad na, no? So if we try to get the net strain along the z-axis, so take note that if this one is three-dimensional, so we may also expect a deformation on the z-axis. But of course, this time, we won't be focusing much on this one because this will be for the one, the triaxial loading. But of course, if the problem will be asking for the behavior of the other axis, which is the z-axis, in response to the strain that is happening with the y and the x-axis. So medyo mukha mo na mabukatan ninyo hang pag-solve sa inyong problema na kay duha na kabuk ninyo hang i-regards or let's say i-pertain ang inyong strain to the z-axis, which is the x and the y axial loading. So most probably dili ka siya magamit because the problem is just asking for the other axis because it's just biaxial. So meaning we're not really concerned with the third dimension or the third axis. So meaning x and y na siya or xz or yz depende na siya sa problem. So it could be, so biaxial loading just 2, di ba? So it could be xy or yz or xz. Depende na siya sa inyong kuan. So you can just manipulate the equation, di ba? So for now is what is presented is just the pair of x and y axial loading. So any questions so far for the discussion? Okay, so magmingaw man, sige, let's proceed. So this is the triaxial loading. So nisa mo to kalabad ang ato ang O, okay? We now have 3 different axial loadings in 3 directions, x, y, and z axis. So that's what is going to happen in this problem. So triaxial loading. So probably I won't probably give you this kaning kuan kay it's too much, and then I think that there are other topics that has importance in the other major subjects. So kaning strain medyo pwede rin siya malimtan as we go along, but of course just try to recall it because apart pa siya sa board exam, diba? But most probably what is coming out in the board exam won't be kaning mga triaxial loading. So probably katong axial and biaxial na siguro, but kani siya murag wala siguro kay again there are other topics that are much difficult to deal with compared with strain. Okay, so this will be the formula. So you have 3 formulas. So you can just try to memorize it if you don't want to understand every detail of it. So probably you can already sense it that it's uniaxial loading plus biaxial loading on the other end. So na triaxial load na siya, di ba? So again, You can already identify the different terms. So you can just follow through with the different items here. Okay, so we have now the relationship between the G and the E. So G again is the modulus. So wala na siya E ha. Pislitan ko rin ako gabi. So modulus of rigidity, and E is the modulus of elasticity. So Poisson's ratio is the nu. So the V variable, the nu. Okay, so modulus of rigidity is equal to E divided by 2 times 1 plus the nu, the Poisson's ratio. So for steel with 0.2% carbon, usually the G for this one is 80 gigapascal and the E is 200 gigapascal, and with the nu of 0.25. So usually in most cases, ang inyong ma-deal with sa mga problems in the higher years will be kaning inani nga steel jud kaning 200 gigapascal, or let's say 200 megapascal, mga inana na mga modulus of elasticity. So for G, most likely you won't be encountering this one much in the higher subjects, also for the Poisson's ratio. So for this topic, alone dyan na siya ang Poisson's ratio. So for you to be able to have a knack of the behavior of the material. Okay. So let's try now a sample problem. So a solid aluminum shaft of 80 diameter, 80 millimeters, is placed concentrically inside a hollow steel tube of inner diameter of 80.0303 millimeters. So meaning there's a small gap between the aluminum shaft and the hollow steel tube. So napa siya enough space to expand, diba? So ironically saying, it's not really enough space to expand because it has only to expand up to 0.0303 millimeters, diba? So it's not really enough space yun. But of course, there's still space yun for the material to expand. Okay, so this space here. Okay, so given that the Poisson's ratio is 1/3, what maximum compressive load P can be applied without causing contact pressure between the shaft and the tube? So modulus of elasticity is equal to 70 gigapascal. So again, if we try to get back with our what we have discussed so far, is that we have here the uniaxial loading, yeah. So uniaxial loading only in one direction. So meaning uniaxial, meaning there's only one axial stress being induced in the material, or one axial loading, di ba? So of course the contact point is this one here, the cross-sectional area on top, which is a circle, di ba? So muna siya inyong timanan. So again, since we are looking for the expansion on X, so if we try to, again, go back with the formula, so nu, or the Poisson's ratio, is equal to the, again, ang katong numerator is katong other axis, diba? The transverse axis. So this time, the transverse axis in our problem is the x-axis, since that is the one expanding due to the vertical load. So this one is negative epsilon sub x. So why is it negative? Because it's positive there. So it's positive because it's expanding, diba? With 0.0303. And then negative epsilon y, because this one is contracting, di ba? So probably this one is this much contraction, di ba? This would be the epsilon y. That would be a contraction, so meaning it's negative. So again, despite having this one here, so it's not really that much of a difference, because even though you have a negative value sa inyong denominator or sa inyong numerator, once you isolate epsilon sub x, the other side would still be negative, di ba? So that would be nu, negative nu epsilon sub y. Okay, so epsilon sub y would now become detailed into its corresponding katong Hooke's law. So negative nu divided by the stress along the y-axis divided by the modulus of elasticity. Okay, so take note that it's correct because we are only experiencing stress in the y-axis. So you can verify that one in your solution, or ma-verify niyo nga sakto ang placement sa inyong mga variables. So again, to start off, the numerator of the Poissons ratio is always the other axis where the load was not applied, di ba? So in this case, transverse, the denominator is the axial axis, di ba? Atong where the load was applied. So again, since it's asking for the compressive load P in the y-axis, so your sigma sub y can be further refined into negative nu. So again, that's force over area ang inyong kuan. So force over area divided by E. Or we can say it as nu times P over AE. Ana, di ba? So pwede siya ana nga direction. So next is so P is unknown. Area can be solved because we have the 80 millimeter diameter information. The modulus of elasticity is equal to 70 gigapascal. So we have the nu also given as 1/3. So how about for epsilon sub x? So again, epsilon or the Poissons ratio is the ratio between the deformation and the total length. So meaning, since you're only required to expand this much, by this much, so we can say that the strain can be further refined into this particular formula, which is coming from Hooke's law. Hooke's law, the deformation divided by the total length along x gapon siya. So negative nu P over AE. So notice na wala pa tayo gibutang na mga numbers, diba? Because we are just trying to understand first the distribution of parameters. Okay, so isolating your P now is equal to deformation of along x and then multiplied by so negative na siya, multiplied by AE divided by L sub x times the nu. So wala mo dyan na siya inyong kan. So let's try to, okay, wala na space, no? Put it here lang siguro. Way to the left lang ha. So further refinement means that our force and then minus the deformation along x. So negative siya kaya atong i-isolate ang p. Then multiplied by the area. So again, since the area is a circle sa top, di ba? So we can have it as pi over 4 times d squared. That's at the top, then multiplied by e. And then the length in the x direction, di ba? So if you go back to this term here, deformation along the length of the x. So it's deformed in the x direction, which meaning ang na-deform ang diameter, di ba? So our L sub x can also be expressed as the diameter. Then multiplied by the nu, which is 1/3. So we cancel out 1d, then cancel out the d in the denominator. So we have here p is equal to the deformation of x times 1/4 pi over 4 rather times d times d times e. And then divided by 1/3. So further giving you as so ato lang iguana. So this would be negative 0.0303. So take note it's millimeters. So pi over 4. Diameter is 80 millimeters. So again, modulus of elasticity, we try to convert it into Newton per millimeter. Para ang ato ang answer is in newtons. So you can just convert it into kilonewtons if the force is too large. Then divided by 1/3. So hopefully this time our answer is correct. So the force,
Negative
pila?
399,799. So negative 400.
So 397.9
399,799. Negative
negative, no?
399,799.
So it's, if in kilonewtons, that would be negative 39.98, diba?
Negative 400, sir.
400 ba?
Yes, sir.
Or 30 ra? Or 40 ra?
399,799, sir.
Mo ba? 39 na lagi diri sa ko. Sige, ato lang i-check sa answer later. So of course, you can see that the force is negative. So just try to ignore the negative because it only pertains that the force is in compression. So of course, dito mo butang og negative, di ba? Because the problem is already indicating the direction of the force. Ano siya? So kilonewton. So basin siguro na site niya ko ano. Oo, it's kuan 399 day kay. Akong pagbutang sa akong ang kuan is just kuan din 7,000 na di ako nabutang sa akong calculator. So it's 399,000 eh. So 399.98 na siya. So that's the answer. So from left to right lang ta. So matag pina-Japanese sa karon, matag nagpasa og manga. Manga. Ano. So from right to left. So starting here, then going towards the left. Okay, so muna siya answer. 399 799.08, or you can have it as 399.8 kilonewtons. So you can have this one as compression, di ba? Butangan nyo compression. Okay, the answer is giving you a negative value. So pili nyo butangan o compression. So obviously compression naman siya, di ba? Kaya nakabutang na sa problem. So murag is redundant gamay. Okay, so any questions for this problem?
Excuse me, sir.
Hmm.
Clarify lang, sir, ba? Unsa gyud ang unit gigamit aning 70,000, sir?
Kaning 70,000 is that would be megapascal.
Sige, sir. Thank you, sir.
So megapascal is equal to, if in terms of Newton per millimeter squared, so muna siya 1,000 newtons all over meter squared na siya. But if in millimeter squared, it's only Newton per millimeter squared. So murag shortcut ba para dili mo magsige convert kani. So express everything in newtons and millimeters. Yeah, I think ang force is you can just adjust it if it's too big, diba? If the problem is asking for the force. So if it's the problem, if the problem rather if the problem if asking for it's asking for the dimensions, so I would suggest that you would express it in this manner, Jud kanisha. Okay, you can appreciate the different dimensions if it's in millimeters. Okay, murag mo na siya labi na sa mga deflection, sa mga inani mga strain. So you can easily appreciate the value of the strain or any deflection if it's in millimeters. Kay kung meters ba murag maglisod tag imagine niya. Ang ato na bang hunahuna sa meters kay murag inana ba murag from the other shoulder to your other end of the hand, di ba? Muna siya ang 1 meter, approximately 1 meter. So if you're trying to imagine 0.00, let's say 0.025 meters, di ba? Murag mata malisod na asa may dapit sa akong kuan sa akong shoulder ang 0.025, di ba? So magnana siya. Okay, so this is the exact solution jud. So murag medyo libog siya. If you try to dissect this one, so I'm going to post the slides later. So if you're going to try to understand the notations of the variables, so this one is delta gamma sub d, delta sub d rather. So this one is the deflection or the deformation in the diameter. So ano na siya, diameter ni siya. Okay, so that's why it's d, di ba? Ano siya. Okay. So this one is again the epsilon, di ba? The transverse axis is always in the numerator. And then the other one is the axial stress, the axial axis. So E sub P is it's referring to the force, di ba? It's referring to the force. So kaya siya is gikopya na sa libro muna, medyo lain niya notation. But katong akong pag-solve kanina, it's using the notation given by the formula. Katong epsilon sub x, epsilon sub y, so on and so forth. Okay, so you have to take note that this one is in this manner. Epsilon sub d is coming from the generalized Hooke's law. This one is coming from also the Hooke's law also, but the other aspect, the stress aspect of it. Okay, so if you're probably asking why we didn't change the strain into, diba? Ang kanishang inyong earlier, so previously is that we change your epsilon y into this formula. So why didn't we change epsilon x into sigma x over E? So again, we didn't change that to sigma x over E because first of all, there's no stress being induced in the x-axis. So murag magtuyok-tuyok ra inyong pag-solve sa problem if you're going to incorporate sigma x over E. And then what takabaon sa atong i-plug in sa sigma x, diba? Because there's no information given in the x direction. Ba wala tay force, wala sa tay given dimension in the lateral area of aning aluminum shaft na to. So ana matang mas stalemate, diba? So muna we look for another way of how we can interpret the strain. So probably my um, tip here is you try to get the two different aspects of strain. So that would be the elongation all over the total length and the katong proportional limit, katong stress all over the modulus of elasticity. So ana siya. So two different variations, but again, you apply it accordingly. So you cannot just immediately apply it as one go nga dapat kanira always, but you also have to think about the problem if it's applicable or not. So again, epsilon sub x, we didn't use this one because at first place there's no stress being induced in the x-axis. So muna siya explanation. Okay. So going back to the discussion. So this is the so muna siya ang inyong epsilon. And then again, this is what we did, diba? Taas lang atong version because ato man siyang detail ng discussion. So probably just keep up with me kay usually I really want to discuss in full detail kana murag step by step jud na kuan ba na process sa kuan formula. Kay murag naanad sa ako ang pag-teach sa calculus gud na kana kayong detail kibaw ko asa na siya gikan, kibaw ko nga kani siya padung didto ana. So that's how I solve my problem should kanang dili pina shortcut pa. So probably mag-shortcut ko if exam, di ba? Kay it's time constraint. But if I want to understand the topic, so muna, go as basic as possible. So dissect each element as much as possible. Okay, so muna siya. So it daghan kayo siya mga gipang kuan. So again, you can just really try to derive the formula first before trying to put the variables in or the numerical values for the variables. Okay, para kaisa ra inyong kuan. So notice here in the problem, so basin maglibog mo, di ba? So this one is in millimeters. This one is in gigapascal. This one is in millimeters. Okay. So the answer is kilonewton. So ang ano kilonewtons man, despite having millimeters. So take note that 70 gigapascal. So pina-shortcut ni siya yaha kanin sa libro. Wala ni siya sa katungkuan sa PyTel but it's from the other reference. So 70 gigapascal, if you're going to express it in kilonewton per mm squared, but this one is 70,000 na, di ba? If you're going to make it as Newton per mm squared. So kana, murag usually the GPA is also the GPA is also directed to kilonewton per millimeter squared. Shortcut po siya. But most likely, ang ako naandan before is katulad yung megapascal ang mo naandan kay. Dili pa kayo used si gigapascal. So if na gigapascal, we just divide by 1,000 sa among final answer. Okay, para it will become newtons. All right, so any questions for this example? Before we proceed to the next one.
So far, sir.
Wala na? Sure, sure. Sige, sige. Let's proceed with the next problem. So, duha lang ka problem. Di na mo deal with sa kuan sa triaxial loading kay hasta ako maglabad akong usad sa triaxial loading. So, kanilang gurong biaxial loading. So, this one is an example of biaxial loading, but at first glance, it's you can say that it's just uniaxial loading, diba? Because we only have one force. So the rectangular bar, 30 millimeters by 50 millimeters by 100. So medyo murag naguba niya kung ano. So dapat it's, di ba, if rectangular prism, dapat length times width times height man unta na, di ba? Para ang iyang notation ba. But our x-axis here is 50 millimeters. So medyo width times length times height siguro ni siya. So probably this is the 30 because it's much shorter. And then this one is the 100 millimeters. So it may seem large, diba? You are dealing with 130, but take note that it's in millimeters. Okay? So meaning the 10 cm, 3 cm, ana, gamay ra kay siya, diba? Comparing it to the ruler. Okay, so it snugly fits between the 50 mm spaced walls. So meaning ana marag haom siya dire, di ba? Perfect perfect siya, perfect. Perfect ang iyang pagka-fit. So let's try to erase this one para not enough space later. Na lang, ako lang siyang ipilit lang dire. Okay, so a load of 80 kilonewton is applied at the upper end of the bar. Calculate the change in length. So the problem is asking for the change in length. So asa man ang length, ana? So again, this is not the length, ha? Length is in the x direction, di ba? Width is in the y direction. Sakto ba? Height by height. Width is in the z direction. Ano? Diba? If you have a rectangular prism, diba? Length times width times height. Ano naman na siya, diba? Rectangular prism. So L is in the x-axis. Width is in the z-axis. H is in the y-axis. So ano na siya? Okay, so the problem is asking again for the change in length. So meaning the change in the x-axis. So meaning it's asking for the change in the transverse axis. So again, by formula, we know that. So now let's start from left to right. So we know that nu is equal to the change in the transverse axis. That's the numerator, di ba? So ato lang i-negative tanan na. Negative then fractional lang siguro. Epsilon sub x all over epsilon sub y. So yun na siya. Okay, then we have epsilon sub x is equal to the negative nu epsilon y. Okay. So take note that since there is no strain in the x direction, di ba? So meaning ana is pwede na siya i-ignore completely, di ba? So kadali sa kaya na ni pop up sa kung kuan. It's a so kani siya it's locking there. So since di na siya uniaxial there, so we are in biaxial. So let me erase everything first. Kalimot ko nga we are in biaxial there. So again, if we try to use the formula, so going back to the formula, kani siya biaxial loading, di ba? Kani siya kani. Okay, so net strain, elongation, and then next is the the next term is the strain caused by the axial loading. Okay. So if you just write the formula, kung tapolo na mo, so pwede siya dito. So ana, the strain in X is equal to so ako kay mag-cheat sheets ako kay murag. So 1 over E, and then that would be sigma X, and then minus nu sigma Y. So muna siya ang first button. Okay. So next is that since we know that the ang inyong rather strain in the x direction is 0, so you may set epsilon sub x as 0, di ba? So meaning ana, we can say that this one is 0 because again, it snugly fits, di ba? So meaning dili kay siya ka-expand. So additional information why it's biaxial. So yung biaxial ang problem, di ba? So of course, there will be a stress being induced in this direction in the x-axis, di ba? A third law of Newton, for every reaction, there's an opposite and equal reaction. So meaning ana, the force will also, the force or the expansion will create a force and then counteracting against the wall, di ba? The wall will react to the expansion. Thus, since it's tightly fit, di ba? Ni-fit siya sa material, so meaning it also suppresses the expansion. So na siya stress pod, but we don't know the exact stress, di ba? So this one is 0, and then this one is 1 over epsilon, diba? And then sigma sub x divided by minus nu. So again, since we know the stress in y, so we can have it as P sub y all over the area. Area in the y direction. Ano lang guro. Okay. So isolating the x variable. So again, since we are not really interested in the the x strain, but again, it's still useful later on because we have to utilize the formula for the strain in the length, diba? So later on, we will be using this formula na sad kani siya. Epsilon sub y is equal to 1 over e. Then the other direction na sad, diba? Okay. Atong kuha na sad. stress from y, or rather, stress from y minus new stress x. Bali na po siya, di ba? Bali nga version. Okay, so we'll get back to this later once we already identified the force coming from the x, ba? So isolating sigma sub x. So sigma sub x is equal to, so it's not really that simple. So let's try to simplify things first. So by expansion, so multiplied everything by e. So don't multiply e to 0 ha, kaya mawa na nun ang e no, di ba? So sigma sub x over e, and then minus v p over a. Ano, pili sa inyo i-multiply para lesser variables. Ato lang i-multiply ah. So sigma sub x is equal to negative v p over a, py over ay. So why did I look for the stress in the x direction? So at first, since there's no given terms in the x direction, di ba? Again, for biaxial loading, dapat duha ka buok ato ang stress, di ba? Stress induced in the material. So it should be in both directions, x and y direction, as what has been stated earlier. But in our problem, we only have one type of axial loading, and that is the 80 kilonewtons in the y direction. So there's no force in the x direction. So again, even though that there's no force in the x direction, since the wall is also inducing some stress, yeah? Again, third law of Newton, for every action, there's an equal but opposite reaction. So sa iyang expansion, diba, it creates force man sa, diba? So again, even though that we don't know really the value or the numerical value for the force exerted by the expansion, we know that it exerts force in the x direction. And that stress is being defined as this one. Negative v times p over a in the y axis. So that's what's happening in this problem, di ba? Sige, basi makalitan mo ba? Ano, nag-start off man ko ani nga, I can just go with the epsilon sub y. So again, if I try to go to epsilon sub y, di ba? If I go to epsilon sub y directly, because it's asking for the change in length in the, since the length is in the x-axis. Sakto ba? Length. Change in quantity siya. Change in height din siya. So again, if I try to, okay, ang change in length is 0 man, di ba? Okay, that's the x-axis. So ang kato ding taas ang yung pangitaon dahil. Okay, so again, if I try to start with this one, so notice that once I try to dissect the formula, so again, this one becomes py over a, di ba? Ay minus nu sigma x. So the next question for me is where I'm going to get sigma x. It's not given in the problem. So that's the time that I need to go to the other biaxial formula in terms of the strain in x. So ana na siya. So again, since I know now the formula for this one, for sigma sub x, so I can just directly substitute it here. 1 over e py ay minus v, so ato lang yung bracket then multiplied by v py over ay. So muna siya akong new formula, di ba?
It should be negative v times
Negative,
PA.
no? Negative,
Yes,
sakto
sir.
din, negative. So muna na siya ang inyong new formula. Okay. So again, the purpose of me getting this one first. So probably ang best tip nga inyong buhaton is try to do, if by actual yung problem, so do this simultaneously. Okay, it will just reflect the other one. Kung unsay kuwang na formula. Ana. Idungan nyo ni og solve. Okay, para maibaw mo kung unsay kuwang. If unsay kuwang, it can be supplemented by the other formula. Okay, since it's by actual, so pair sila, di ba? It's a pair of formulas. Okay. So this one is negative PA because again, the force is going downwards. So ano siya? Okay, so if we try to plug in now the values, so let's check if everything is okay now for the replacement of the variables. So okay na siguro siya. So 1 all over 110. So let's try GPA ha. Okay, para ang atong answer is in kilonewtons. Pero murag pwede rin siya kay kilonewtons mga atong value dahil. So negative 80. So again, kilonewtons, wala ko gi-change ha. So again, GPA is equal to kilonewton per mm squared. Shortcut, another shortcut if you want to try to do some shortcuts of conversion. 80 over the area. So again, length times width times height. So probably just multiply this one. So area is 50 by 30. So that would be 150 now. 1,500 1,500 mm squared. So 1,500 mm squared, and then minus the nu, which is 0.35, and then minus 0.35. That would be negative 80 still all over 1,500. So naghuot yun, no? So strain is equal to, so again, ang change in length, that is referring to through the sa strain as yeah. So change in length is different from elongation. Elongation is the delta of a smaller case. Diba? This is elongation. If it's asking for change in length, that would be strain. Again, basic definition of strain, that would be deformation with respect to the length, diba?
Negative 0.54 Newton, sir.
Newtons, di na siya newtons ha?
In kilonewton, sir, kay kuan siya, sir, 5.44 times 10 to the power of negative 4.
Asamaan ni Dapitang answer.
Ang kan answer, sir.
Di na siya kilonewtons ha, it's millimeters.
Millimeters. Yes, sir. Millimeters day, sir.
Pili answer?
5 times 10 to the power of 5.44 times 10 to the power of negative 4.
Okay, sige. And then sige, so it's times, pili ito? Negative
Negative 5.44 times 10 to the power of negative 4.
then this one, since it's strain, so muna siya inyong value, but if it's if you try to change it in elongation, so again elongation is the deformation divided by the length, diba? Divided by the length is equal to the strain. So i-try daw og plug in siya. multiply by, pinaman siya, did I? Multiply by 100 man siguro.
Times 100, sir.
Pero lahi lagi ang answer sa ko, ano?
Negative 0.05, sir.
Negative 0.05. So that would be millimeters. So muna siya ang elongation, ang deformation, elongation or deformation. So negative 0.05. So sakto siya, it's negative because it's going down. But the answer is, sige, ito i-check ha. So this is the answer. This is the formula. So medyo libog ka siya kay ang iyang notation sa iyang x, y axis are interchanged. Sa ako is ako tong gisakto ako ang kanya siya x yun na siya, kanya siya y, and this one is always z. Moto sa ako ang pag-solve sa problem. So that's why I started with this one. So instead of strain along y, it's strain along x to ako. And then this one is x. Sa ako ang solusyon na. Then this one is py over ay. So in this term, probably sakto ram siguro to 0.005, but sakto ram sa itong ibuhat. So this one is y in the problem, in my solution, y, and then x. This one is py, ay, and then pa, ay. So ano siya, py, ay. Na, for you to be guided. So probably it's katong 0.05 is correct na siguro to. Probably it's some sort of pag-declare sa numerical values, but it's closer to the answer, 0.00425. Okay, sakto naman to, di ba? 80, 100, 110 atong ibuhat. Okay, so dapat ang answer ato is strain since you're asking for the change in length. But if it's asking for elongation alone, so you have to refine the details of your answer into its corresponding conjugate variable na elongation dyan siya. Aning delta sub y. So sige lang, ako na siyang i-post ang inyong kaning slides for you to be able to review this one. Okay, so any questions for the simple strain? Not really simple, di ba? It's complicated strain. So questions for uniaxial and biaxial loading. So again, I won't be dealing much with triaxial loading kay murag. Probably I can say that it's only important for you to go to the third axis if you're studying for higher subjects like for masteral. So probably if you go that if you go to that level, siguro, so probably siguro you can focus much more on the third axis, which is the z-axis. Okay, so if you don't have any further questions, so probably this is it for this session. And on next Tuesday, we're going to discuss another topic, which is statically indeterminate members. So these are members wherein there are greater number of unknown forces compared with the given equilibrium equations. So muna siya statically indeterminate, more unknown forces compared to the 3 equilibrium equations. All right, so if you don't have any further question, so that's it for today. Thank you for listening, and I hope that you were able to understand the simple yet complicated strain topic. So
Last
thank you
question,
very
sir.
much. Sige.
Last question, sir, ka na. When ang midterms exam sa mechanics, sir?
Koan, as think I can pwede na kita mo go beyond sa expected date kay again I'm trying to achieve first the topics for midterms ana.
Sige,
Yeah.
sir. Thank you, sir.
Yeah, ganahan ko nga kanaging dili siya dali pagka-discuss kanang dapat makasabot mo sa each topic. Dili ngo na gidali na ako just for the sake nga makaabot ko sa midterms nga schedule ana. Okay?
Sige, sir. Thank you, sir.
Sige, sige. So, any other questions? Okay, so hearing
Or, sir.
none. Sige, so if there's no question, so see you all next week.
Bye, sir. Thank you, sir.